Hey there guys, Paul here from theengineeringmindset.com. In this video, we're going to be looking at air-cooled chillers to work out and learn how they work. Now, air-cooled chillers are very common, especially in newer, smaller, medium, high-rise buildings such as office blocks, exhibition halls, these kind of buildings. Now, air-cooled chillers do not use cooling towers. They dump their heat, the unwanted heat, straight into the ambient atmospheric air. They therefore need to be placed outside, so you will usually find them on the roof of a building or maybe on the ground floor, around by the car park, something like this. But if you have a look on the roof, if you can get up to somewhere high and look across some buildings in a city, you'll probably see like there's an air-cooled chiller here, there's some more here, there's some condenser units here, there's some more here. They're very common across these kind of small to medium sized buildings, and they're usually on the roof just because of the space requirements. So they're very popular simply because they take up a lot less space compared to a water-cooled chiller. They don't need water to dissipate their heat, whereas obviously a water-cooled chiller would. It would dump its heat into a condenser loop and push that up into the cooling towers. So you'd also lose water from the system there. However, air-cooled chillers are less efficient compared to water-cooled chillers because they don't use the latent heat of evaporation. But anyway, let's jump straight in and just see how these things work. So first of all, we've got a simplified 3D schematic of a typical air-cooled chiller system. You can see we've got the two air-cooled chillers up on the roof, and they've both got small chiller pumps on there, circulation pumps, so they'll pull return water in and push that through the evaporator and then push that cooler water back out into these headers. These will run along and then enter into the main pumps over here. The main pumps will then push that water, usually one of them will run at a time, there might be duty standby, and that will then push that chilled water around the building to wherever it's needed, off into the AHU, the fan coil units, etc., around the building. Once that has been used, it will then return, it will come out, so it will probably go in at around 6 degrees Celsius, which is about 43 degrees Fahrenheit, and it will then leave here back into the return at about 12 degrees Celsius or 54 degrees Fahrenheit. Now, all of this will then add up into these are known as risers, and that water will then, it's still called chilled water even though it's now warmer, but it will then return, so this is return chilled water, and that will make its way back up to the top here, where it will then enter off into the chillers and repeat that cycle. So let's now have a look around the chillers to see the main components, and then after that we're going to have a look at a bit more detail on how they actually work. So first of all, if we look at the air-cooled chiller from an isometric view, you'll see that on the top is the condenser cooling fans. Now when these rotate, they suck air in, the ambient air from the outside, and they pull this in through these grills and through these holes, and also through these grills here. So they pull all this air in and then they push that air out through the top. And as that air comes across there, it will take off some of the heat away from these pipes and then push that out and away into the ambient air. So that will take the heat away from the refrigerant, and we'll look at that slightly later. But if you imagine, say if you've got a cup of hot tea, if you imagine this is sealed there and it's hot, then you would blow across the top of this to push some of that heat away and cool it down so you can drink it. And that's much like what the fans are doing. They're just pushing that heat away, although this would be a sealed unit with a hot refrigerant inside. But the real world fans, just look at something a little bit like this, just a slow down animation I've done here. So you can see that just rotates, a very small motor on them, and there's a number of these on the top there. So then if we just kind of change the view there a bit. And the next part we'll look at there is the compressor. So the compressor is obviously the driving force of the refrigerant around the system. In this case, I've just put a screw compressor in here. It's usually a screw or a scroll or reciprocating. So a real screw compressor will look something like this. But if you want to know a bit more about compressors and how they work, I'd highly recommend you to check out one of our other videos, chiller compressor types. I'll put a link up here as well. But if you go through here, then we'll just go through in a bit of detail on all the different types of compressors and how they work, very basically. But anyway, so the compressor pushes and forces the refrigerant off through these tubes and off into the headers here, and off into towards the condenser. So these are all the condensers, we'll see that in just a minute. But the refrigerant will leave here as a high pressure, high temperature, superheated vapor. And if we then change the view of this one again, so then you can see that obviously this part here is known as the condenser. So the hot refrigerant is coming from there, from the compressor, and it will pass through the tubes within this condenser. And you'll see there's a number of loops. We'll have a look in detail of how that works as well shortly, but it will pass through here and make its way out and then into this header here. And by the time it leaves the condenser, the refrigerant will be a high pressure, medium temperature, saturated liquid. And obviously, as we saw earlier, the condenser cooling fans are going to be pulling air. You can see all the way through this one now. So these fans will be pulling air across these hot pipes, and that will be sucking the air away and pushing that out into the ambient atmosphere. So if we change the view again on this one, then you can see on this end all the refrigerant will then collect up after it's cooled down in the condenser, and it will then flow into these headers and make its way down into the filter dryer. That will then pass through there and make its way off and up into the expansion valve. So again, by the time the refrigerant starts and makes its way to the expansion valve, the refrigerant should now be a high pressure, medium temperature, saturated liquid. So we just changed the view on this one as well. And from this one we can see that the refrigerant, after it's passed through the filter dryer and into the expansion valve, is then going to make its way and pass into the evaporator. So this big tank at the bottom, underneath all this stuff, this is the evaporator. So this is where the return chilled water, if you remember this water just here, the return water, so that's where that's going to enter into it, pass through the evaporator and make its way back out much cooler. So we've got one entrance which is coming in, and that's coming from the buildings and the AHUs and the fan coil units, and it makes its way through there. We'll have a look inside this one shortly as well, and it will then make its way out back off around the buildings, the AHUs and the fan coil units, to provide that cooling. And the water will usually flow in the opposite direction to the flow of refrigerant, and that's where you get your maximum heat transfer and your LMTD, or log mean temperature difference. So when the refrigerant has now left the expansion valve, it will then be a low pressure, low temperature liquid vapor mixture, and it will then pass through the evaporator and absorb all the unwanted heat that's come back from the building. Once the refrigerant has passed through the evaporator and is making its way back to the compressor to start the circuit again, then the refrigerant will be leaving the evaporator as a low pressure, low temperature saturated vapor. So that is the basic cycle. It then passes around. Remember, the refrigerant never leaves the system. It's a closed system. It just passes round and around and around and around through these main components. So let's have a look at how each component works in a bit more detail. So we've got an animated version here, so you can see inside the chiller, the air-cooled chiller, to see what's happening in there. So first of all, we've got the compressor, and again, it's a screw type. That doesn't necessarily have to be in every case. Check out our other videos to see about that. So the refrigerant is going to be pumped out there, it's going to be pushed out there by the compressor, and that's going to leave as a high pressure, high temperature, superheated vapor, and that's going to make its way to the headers of the condenser. Now I'll just give you a real world example here of some of the headers. So this is the distribution headers here, pushing that through. This one has got the flow and return, so it goes there and comes back. You can see it then runs into the filter dryer there. But anyway, we'll have a look at that in just a second. So it's coming from the compressor and it's making its way through these distribution channels, and you can see it teeing off there and going through the coils within this condenser to dissipate its heat. And then we've got the condenser cooling fans, so these will be rotating, and that will be pulling the cooler ambient air across these coils. Remember here we've got the flow and return. It makes its way all the way throughout the loop. Have a look at that as well in just a second. So it's going to pull the air across that and extract all the heat away from the surface of this pipe. These fins which are in between it, they're incredibly thin, and they're very easy to damage as well, so be careful if you're working or touching these. and these fins basically help to transfer that heat away from the pipes and out into the stream of the flow of air, so that increases the heat transfer surface area and the effectiveness of the heat exchanger. So now we can start to see some of that refrigerant as it's coming in off this distribution header and passing through the coil. So you can see it's made its way around the first part there, and it's already started to cool down. It will then make its way into the second pass. So this is a 3-pass condenser, 4-pipe 3-pass condenser, 1 pass, 2 pass, and then the 3rd pass back and then towards the exit. And then finally you can see it's cooled all the way down, and it's made its way off into this collection header. So by the time the refrigerant leaves the condenser at these points here, that should all be a high pressure, medium temperature, saturated liquid. So that refrigerant will then make its way through this collection header and down towards the filter dryer. Now the filter dryer, all it's going to really do is it just absorbs any water to stop, the water will become like an acid, so it will stop that passing through, and it'll also take some, it will just filter it a bit, get out oils and things like this to stop it making its way off and into the compressor really. So once it's passed through there, it will then make its way up into the expansion valve. Now just to show you a real world example, we've got a filter dryer here passing along and up and into an expansion valve just there. This is a thermal expansion valve. You can see it's got the capillary tube going off there to the other side of the evaporator. That's what controls it. If you want to learn more about how the expansion valves work on chillers, I'd highly encourage you to watch our video on chiller expansion valves. I'll also add a link up here as well so you can have a look at that. But basically we'll just go through different scenarios and how they work and the different types and varieties that you'll find. So have a look at that video. But anyway, so the refrigerant will then leave the expansion valve, and that will make its way then off into the evaporator. Now the refrigerant here, as it leaves the expansion valve, is going to be a low pressure, low temperature liquid vapor mixture, and that will then come into the evaporator. It will kind of spray into these kind of called water box, but there's refrigerant inside it, and the refrigerant will then split apart and enter it into these different tubes. Now this is known as a shell and tube heat exchanger. So one fluid would be in the tubes and another fluid would be in the shell. So in this case the refrigerant is going to be the one that passes through the shell. This is slightly different to a water-cooled chiller where it would actually be the other way around. But anyway, so yeah, so the refrigerant passes through here and it will start to give up or absorb some of the thermal energy that's coming in, and we'll have a look at that in just a second as well. So by the time the refrigerant leaves the evaporator, at this point here, it's about to go off into the compressor. That should then be a low pressure, low temperature, saturated vapor. Now if you remember, we had the chilled water, the flow, and then also the return coming into this evaporator, so we'll have a look at that as well. So then passing through the evaporator, we've then got the chilled water coming in, so it's passing in, it's coming in the return water there, and then making its way through and out around the building to provide that air conditioning, and it's absorbing all the heat from the unwanted heat from the building and bringing that back to the evaporator where it will exchange the heat with the refrigerant. So the refrigerant never leaves these tubes, it's always contained within them, and the water then passes around on the outside of the tubes to absorb that thermal energy and take it away. Also notice that there's some restrictions within the heat exchanger. These are known as baffles, and what happens is the chilled water enters here and you'll get much greater heat transfer if the flow of water is turbulent, or the fluid is turbulent. So you add these baffles in, and that will cause the water to change direction sharply. In the animation it's a bit smooth here, but this would really be very turbulent in there, passing through and colliding and moving across the surface of these tubes and taking more and more of that thermal energy away, so that it leaves as a very cool liquid ready to go around the building again. So you can see it's fairly similar to the water-cooled chiller. This is a setup obviously for a water-cooled chiller here, where it's got a different loop which goes off to a cooling tower, and you've got more pumps, etc. So you can see why the other version is more popular, but the water-cooled chiller is much more efficient. Now, if you want to learn how a water-cooled chiller works, then check out our video here on chiller basics. How do they work? We go into quite a bit of detail. Also, I'd highly recommend that you check out the second video here, the part 2 of how they work, when we go into it in much greater detail. But anyway, that is it for this video. Thank you very much for watching. I hope this has helped you learn how air-cooled chillers work, at least the basics. If you have any questions, please leave them in the comments section below. Also, don't forget to like, subscribe, and share, and also check out our website, theengineeringmindset.com. Once again, thank you very much for watching.